Hello friends, this is Dr. Ravi Sani. Our today's discussion topic is random error versus systemic errors. No matter how careful you are, there is always error in a measurement. There is always a possibility of error in measurement. In science, measurement error is called experimental error or observational error. There are two broad classes of observational errors. First one is the random error and second one is the systemic error. Random error varies unpredictably from one measurement to another, while systemic error has the same value or proportion for every measurement. Random errors are unavoidable but cluster around the true value. Systemic error can often be avoided by calibrating equipment, but if left uncorrected, it can lead to measurements far from the true value. So, errors varies unpredictably from one measurement to another. If we will uh, take a measurement again and again, then it might be possible that every time we will encounter a different type of error. Then it is called random error. In case of systemic error, every time when we take a measurement, then the same value or proportion of error will find again and again. So random errors are unavoidable, but the systematic errors can be corrected by calibrating the equipment. So the key takeaways are: random error causes measurement to differ slightly from the next. It comes from unpredictable change during an experiment. Systemic errors Systematic errors always affect measurements the same amount or by the same proportion, provided that a reading is taken the same way each time. It is predictable. Random errors cannot be eliminated from an experiment, but most systematic errors can be reduced. Like I've already mentioned, in case of random errors, every time we will take a measurement, then different error we will encounter. But in case of systematic errors, if we will following the same process for measurement, then every time we will encounter the same error. Then it is called systematic errors. So systematic errors can be reduced, but in case of random errors, these are not easy to remove. So these are the various examples of random errors and their causes. Like when we weigh ourselves on a scale, then our position is slightly different each time, which can cause random errors in measurement. When taking a volume reading in a flask, you may read the value from a different angle each time. It might be possible that if you change the angle, then the value of measurement would be changed. Measuring the mass of a sample on an analytical balance may produce different values as air current affect the balance or as water enters and leaves the specimen. Measuring your height is affected by minor posture changes. Because random errors always occurs and cannot be predicted, it is important to take multiple data points and average them to get a sense of the amount of variation and estimate the true value. Now the examples of systematic errors and their causes, like uh, forgetting uh, or zero a balance produces mass measurement that are always off by the same amount. An error caused by not setting instrument to zero prior to its use is called an offset error. Like it is a fault of calibration. Like if we are not uh, uh, setting an instrument at zero or at the initial level every time, then definitely we will encounter the same error in every measurement. Not reading the meniscus at eye level for a volume measurement will always result in an inaccurate reading. The value will be consistently low or high depending on whether the reading is taken from above or below the mark. Systematic error can be minimized by routinely calibrating equipment using controls and experiments, warming up instruments prior to take readings, and comparing values against standards. Like in case of systematic errors, every time when we take measures, instrument should be calibrated and the value should be set at the initial level.